So the task framework that David just demonstrated implements our core use case, and that is the distribution part of distributed async await. Right? So async await is managed, or the execution of async await is orchestrated by an event loop. Right? And similarly, the execution of distributed async await is orchestrated by a distributed event loop. And the heart of the distributed event loop is the task framework that David just demonstrated. And the task framework is, in essence, a supervision framework. The task framework ensures not only reliable message delivery, but it ensures reliable message processing by being able to take heartbeats on the task. And when a heartbeat is missing, we assume that the executor crashed, and therefore we reschedule the task. So the task framework is a generic supervision framework that is responsible for reliable message delivery and reliable message processing. On top of the task framework, we now layer our mechanism that makes distributed async await work. And unlike, for example, most RPC frameworks that assume a quote-unquote synchronous call, right? So you call something synchronously and then you await its response, often having an active TCP connection established, right? And however, we have a distributed async await, which is where every async execution is an independent unit of execution, and you can await at different points in time. So there are basically two messages flowing through the system on top of that task framework: invocation and resumption. Invoke, resume, invoke, resume. The entire system orchestrates in terms of these two messages. That is, you have a caller, and the caller invokes a callee, right? We do that by creating a promise. And the creation of that promise signifies that we want to start an execution. And then we await a promise, right? And when the promise completes, that signifies that we want to continue, resume execution. Now, in async await, that is a single node, right? We're dealing with function pointers because we can directly call a function, right? This is a distributed system. Therefore, we cannot deal with function pointers. The equivalent here being messages. We deal with messages, right? So where the event loop calls a function, the distributed event loop sends a message. So that's the first part of the equation. The second part of the equation is that, like, I can give the event loop any function pointer, right? So it's like the event loop doesn't really care. So I hand it a function pointer, and then the event loop just calls it. We can't do that. So what we do is what's also called defunctionalization. So instead of calling a function, we have a command, right? And so our system is composed of two different commands, and that is invoke, resume, invoke, resume. With these two different commands, we actually can guarantee end-to-end progress on top of our generic supervision framework.